we're on to probability trees. So this is page 54 of our notes, and we're looking at this particular problem here. So what I'm interested in doing is looking for the probabilities first of all, okay? So I've been told that there's an award and it's either accepted by the captain, or if they're absent, then the vice captain. And it tells us what percentage of the time the captain's present and the vice captain's present and so on, okay? So what I want to do is I want to take that information and draw myself a probability tree. So the first thing I need to do is think about the sequence of events. So what I'm going to do is, first of all, there are two things that could happen, okay? If the captain is present, then the captain will receive the award. So that's my first event, is whether the captain is present or whether the captain is absent. Okay? Then the second event, then we've got to think about, okay, well, if the captain's not present, so say the captain was absent, then we've got to think, well, was the vice captain present, or was the vice captain absent? And that could also be true if the captain is present. So if the captain is present, the vice captain can also be present, or the vice captain could be absent. So the first event is about whether the captain's present or not. So that's that first section. Then the second event, the next level, is the next thing that would happen is looking at whether or not the vice captain is present or absent. So that's our two layers of the tree. Then we've got some numbers that we need to put on there. So if I look at our first sentence, it talks about if the captain, okay, so the captain of the hockey team is present in assembly 95% of the time. So that's just straight talking about the captain themselves, okay? So that means if I look at my captain being present, the captain is present 95% of the time, which is 0.95 as a decimal. Now, if the captain's there 95% of the time, then there'll be 5% of the time, or 0.05 of the time that the captain is absent. These two numbers here must add up to 1, because all probabilities have to add up to 100% or 1. Okay, so that's the first number dealt with. Then let's go back again and let's look at our next sentence. So now it talks about the vice captain is present in assembly 93% of the time that the captain is present. So they're telling us when the captain is present, the vice captain is present 93% of that time. Okay, so we're interested in when the captain is present, so they've told us that. They've told us that when the captain is present, the vice captain is present 93% of the time, so 0.93, which means there's 7% of the time that the vice captain is absent if the captain is present. So that's going to add up to 1, so that is going to be 0.07. Then we look at the third step. So the vice captain is present in assembly 75% of the time when the captain is absent. So now we're talking about when the captain is absent, and 75% of that time the vice captain is present. So we can say from when the captain is absent, the vice captain is present 75% of the time, or 0.75. So that has to add, those two have to add up to 100%, so this is going to be 0.25. So 25% of the time when the captain's absent, 25% of the time the vice captain will be absent. Okay, so that's the first thing we've got to do, is set up the table. Now the next part of the setup is being able to calculate the probabilities. So what I'm going to do now is down the side here, I'm going to create another column. And this column here is going to be about the probability. So the first one is I'm going along this branch and along this branch. So the first probability is when the captain is present and when the vice captain is present. So this probability and this probability. Notice that keyword and. Remember and means multiply. So when I go along the branches, I'm multiplying. So that probability is going to be 0.95 for the captain being present, times 93% when the vice captain's present. And when we multiply those out, that is going to give us 0.8835. Okay, so that represents the captain being present and the vice captain being present, both of them in an assembly. Then I'm going to look at the next branches along the line. So I'm going to go captain being present and the vice captain being present. So now I want to know the probability of the captain being present and the vice captain, and I'm going to put a dash there because that dash means not. So the captain is there and the vice captain is not there. So that little dash is not. And that probability is along the branches of 0.95 and means times, and we're going down this branch, 0.07. And that gives a probability of 0.0665. Okay, so that's dealt with that combination and this combination. Now we've got two more combinations. We've got the probability that the captain's absent but the vice captain is present, and the probability that the captain's absent and the vice captain is absent, so they're both absent. So that's what we're going to do now. So first of all, we're going to do captain being absent. So I'm going to do C dash, so not the captain's not there, and the vice captain is present. So and the vice captain. So going along the branches, we've got our 0.05 and means times, and our vice captain being present, that probability is 0.75, and that gives us a probability of 0.0375. Last but not least, the last combination is when the captain's absent and the vice captain's absent. So the probability the captain is absent and the vice captain is absent. And we're going down the branches, 0.05 and means times the vice captain being absent, 0.25, and that gives us a probability of 0.0125. Now, if you remember how we talked about these two numbers had to add up to 1, these two numbers had to add to 1, these two numbers had to add to 1, the same is true of all of these numbers. So if I took 0.8835 plus 0.0665 plus 0.0375 plus 0.0125, so those four probabilities there, if I add them up, they're going to add up to exactly 1. Okay, so all of those probabilities also add up to exactly 1. Okay, now what we're going to do is, so now that we've set up the problem, now we want to actually look at what the question that's being asked. Okay, so I haven't even looked at that until I've got the setup done. So now the question itself. Calculate the probability that both the captain and the vice captain are present in this assembly. Okay, so let's think about what combination that refers to. The captain and the vice captain are present. So now if we look at this, we've got our captain being present and we've got our vice captain being present, and the probability that both the captain and the vice captain are present is 0.8835. Okay, so the answer to question A is that the probability of the captain and the vice captain being present is 0.8835. Then part B, let's have a look at the next question. Calculate the probability that the award will be presented in this assembly. Okay, so the award, if I go back up to the top here, it says the award must be accepted by the captain, or if the captain's absent, the vice captain. So that tells me that if one of them is there, or both of them are there, the award will be presented. But if they're both away, the award won't be presented. So let's think about, well, what does that mean? So that means I could have the probability that the captain is there and the vice captain are there. Or, so remember, or means plus, so this probability, or I could have the probability that the captain is present and the vice captain is not present, or I could have the probability that the captain is not present, but the vice captain is present. Okay, so those are the three possible combinations, 1, 2, 3. And each of these three things, either both are present, captain's present, or the vice captain's present. Okay, so that's going to then, if I add those numbers up, 0.8835 plus 0.0665 plus 0.0375, that will add to 0.9875. Now there is an alternative way that I could have done this particular one. I know that all of those four combinations have to add up to 1. And because they've all got to add up to 1, I could add those three, or I could say, well, all of them together is 1, take away this one, will leave me with that probability added together. So this is also the same as saying 1, take away the probability, the captain's absent and the vice captain is absent. So 1 take away 0.0125 is going to give us the exact same answer of 0.9875.